Okay, so I'm making this video to showcase some of the features of R that I really like and that I think are basically superior to Python. I had a conversation with my friend Jonathan Ng the other day, and in it one of the topics we covered was R versus Python. And I kind of thought I didn't realize it was still like a common thing that people talk about, R versus Python. That was very much kind of a thing last year that I saw on social media. But after the video, I got some messages from people who were just starting out and like new to data science. They'd learned the first couple of lines of like R, and then they're like, it's a serious decision they have to make as to how they spend their time and invest their time to build those useful skills, right? So, I just wanted to make this video as a way of kind of exploring that topic and the things I like about R, because I do think that R has like a place in certain environments, and it has superiority over Python in certain ways, but Python also has superiority over R in other ways. And I think this kind of exploratory data analysis where the output's like a document is really strong in that area. Especially when you're doing like modeling, like not production machine learning, but statistical modeling and exploration of data. I think R is a superior tool. So if that is like where you want to be going with your work, then R is potentially a superior tool. If you're an economic analyst, and you're currently using spreadsheets and you want to up your game, and really take things to the next level, then R is a good way to go. Or looking at economic data. The motivation for this document that I made, I was looking on Kaggle at data sets, and I came across an economic freedom survey that had been done by, I think, maybe the Heritage Foundation or some kind of economically liberal organization, and that's kind of an interesting idea. Fundamentally, economic freedom is one of the things that, as soon as you think about it, you can see that it's a trade-off, right? So economic freedoms, things like the rights of the ability for people to like go start up shops and start businesses, but also things like land use and natural resource use. So if you have strict protections on natural resources like forest or wetland, and on like wilderness like mountains, that's going to like prevent people from deforestation, or like draining wetlands for agriculture, or things like mining activities. So that's like a trade-off that would be interesting to explore, whether if you could take that economic freedom data, and then look at markers of or indicators of like economic prosperity, like material wealth increases, and then contrast that to like environmental degradation or any kind of things of that. So that was kind of the motivation or the starting point. And then I had already had the economic freedom data, and then I wanted to dig into some economic metrics. So the World Bank was a data source I found for that. And they have like a wide range of these economic indicators on their package, and in R they have this World Bank stats package. So I got that, and then I basically spent an afternoon kind of digging into that and playing with it, and found some interesting kind of stories in the data that I'll go through in this, and then never really did the economic freedom analysis that I wanted to, because I'm not doing a PhD in this. This is something I did in an afternoon. I ran out of time, and then I had an idea for a new cool and exciting project. So hopefully I'll tidy this up and publish something. But one of the reasons I want to make these videos is that I can just go over kind of work in progress projects, and kind of see what people are interested in, and hopefully get some motivation to get something finished, or maybe pass it on to someone else who's interested. So the tools we used in this thing are the tidyverse, which is a set of R packages. It's like a meta package that includes a wide range of useful packages for like dealing with data in this kind of tidy way. So they've got a consistent syntax and like structure. And so once you kind of get to the package, it's all very intuitive. It's all really beautiful. It's this the tidyverse is, I think, the best exploratory data analysis environment that I have seen. And like I would compare that to like pandas in Python. I think tidyverse is far superior to pandas for these tasks. The way that the grammar, the verbs work with the pipes, which we'll see shortly, is really nice. We also have the World Bank stats package. We've got Knitter, which helps to build our Markdown documents. Cable Extra, which helps you customize cables, which are like a type of table. We don't really need to talk about that. I've actually removed the cables from this document because they don't render well in the this kind of text environment. And then the Tidy Models package, which is like a tidyverse approach to modeling in R, and is really good for like exploratory modeling, which is kind of a topic I'll brush up on, but I'm no means an expert on. But it's a really interesting area of data analysis that doesn't get talked about as much, and it does require like an understanding of actual modeling, like statistical modeling versus just throwing like a machine learning model at some data and just trying to get a prediction out. And it helps. It should give some idea of like the things you can do with like statistical models, like even like neural nets and like gradient boosted machines and random forests and stuff. They're still models, and they still have other properties rather above just like raw prediction. And it also shows that like a bad fit for a model can be like a useful outcome of analysis. So yeah, I think that's interesting given that we live in this current fascination with just prediction of these statistical models. And yeah, but I'll get to that. For now though, there's some basic work on this data. So we pull it in to countries as a data. We pull the data in for the World Bank. We get the cache list, which is just like some data that's stored in the package. So we just take the countries and we just put that in there as a data frame or a tibble, which is a special type of data frame with some better properties in the tidyverse. I then throw out some columns with this select thing. So I take my data frame, and because like all the tidyverse, there's a range of these functions which can be applied as operations. So I can apply, instead of like using a method to like drop a package, it's not chaining methods, it's applying functions to data. So you're passing your data through these functions. We can use the pipe operator to kind of to make that easy to read. So you're reading left to right rather than like inside out. Because if we didn't use these pipes for this operation, we'd have to call mutate on countries and then select on that. The other way around. We'd take countries, then we'd apply select, and then we'd then have to call mutate on that, which would, you'd have to read left to right, but that's not really the way we think, right? Or right. This is a pipeline. I take countries, and then I want to do a select to it, which is similar to like select in SQL in that it allows you to choose the columns you want. So here I can use like a negative select to throw out these columns, which is a really useful feature, just being able to remove columns from your data frame in like an easy syntax. And then mutate, which allows you to make new columns or change the value in a given column if that name already exists. So I just change the data types of let and long here. And because it's R, I don't have to quote anything. Like the way that R is evaluated, I don't have to. I can pass objects and they can be evaluated as names, like in the context when it gets to the when it gets around to evaluating it, it then can work out that this is that this capital is like a column. The way that the code works. So that's like like R is designed in such a way that you can do that, whereas I'm not sure you could do that in Python, and I don't believe you could. But I'm not like a complete expert on like the mechanics of either language. Like I'm not a core developer for either. But that is like some of the advantages of R. Right? They are R and Python are architected fundamentally differently, and so so they're not the same language. They don't work in the same way. Is the message I'm trying to get across here, which is something to keep in mind. Like computer languages are built differently, and so it's not just about what functions are available. There are underlying things that matter. Then I just take some more data. So we just take irrigation here. So I get some more data, which is like irrigation data from the World Bank, and then I make it into a table. And then I just make the date numeric, and then we can have a look at the header of that, like the head rather the first 6 rows. We see it's got some like years and numbers, and some country codes and stuff. Nothing particularly exciting in that. But it's good to note that this code here is different. Sorry, to this code. Sorry, this code here matches this code, which I think I will use for a join later on. So it's good to look at your data and like see what you can join on and get a feel that everything's working right. Here we get some tractors data because I was just looking at like farming data at this stage. I was like, well, that's I'd forgotten about the economic freedom, and I was just going, well, what if I can predict crop yield? We'll start and see if I can do some modeling and like predict, say, crop yield from some like key other indicators like cereal yield as like a starting point with just this data set, get a feel for it. And as I followed through, that was kind of a good way to go because as I pull more data out, we'll find that it's not the data set is incomplete. They're not completely overlapping. And so in the real world, you don't just have the data that you want. Like if I was on Kaggle, they'd give you this nice table that has all the data that you want already there, and it's just like build a model out of that. But in this real world situation, I had to, I can't. I run into a solid wall where there just isn't the data for the thing I wanted to do. So I might have to go somewhere else to like change my approach. Anyway, cereal yield is another good indicator, I think, or it's like the target that I was interested in. I was like, well, can I predict this value based on fertilizer, the number of tractors, and like irrigation? There might have been some others, but I think I thought that was a good data set. So I select some columns here and rename the things because I wanted to do a join. So my 4 data frames, I wanted to join them together. I was like, well, I'll name the columns, the value column. So I'll change the value column. I'll take just the columns I need so that I can do like an effective join. Which really is that and that, because I don't want like the year 2000 to be connected to like 1995. We also have these Arab world things, which is something that I deal with later on. But then I make a data frame out of that, joining there on my countries. So I have that countries table from the beginning, which is only countries. So it doesn't have like the Arab world as a country in that country's data set. So when I do a left join onto that, I'm only going to be adding new rows onto that data set, and then I'm going to do it on this country code. And once I've joined the first irrigation irrigation reduced, once I've joined that onto countries, that there becomes my data frame, right? Because I'm just piping on top of it, and then I can use the date to join onto that after that. And then I get a new data frame, and then I get a new data frame, and then I get a new data frame. What I end up is this big data frame with all my countries, with years, and some other kind of data at the countries. And then we start to see the issues like there isn't tractor data for every year for every country. Straight away we see that. So I decided to have a look and see what was going on with these with the thing, so I can use the summary feature in R. It's a super useful thing. And I can see there's like hundreds of NAs there, 874. So there just isn't as much tractor data as I'd like. So I thought I'd have a look and see what was going on. Turns out it has brought in like Africa here as like a row. So yeah, contradicting myself a bit here. But anyway, so I can find where the column long is null, and I can just do a filter operation. That's pretty like a really useful operation. So I can find, I get like 11 columns. Still, that's not. Yeah. But what we see critically is that these are these don't look like countries. Actually, what I want is so what I actually want is to get country here, and then distinct, which gets me 93. So we are actually getting like Curacao, Gibraltar, which is like an autonomous region, right? And I think like it's not an independent nation. So as you look through it, West Bank and Gaza, again, like Palestine. I mean, not an official country. Taiwan, China, St. Martin. So yeah. So what we end up with when we look at like what's missing with the longitude data is that it's a whole bunch of kind of non-country regions or non-nation regions. So we can just throw that out. I don't actually care about those rows, and then we can have a look again, and we see we got some missing date, which is the same as that as the irrigation percent of land. So maybe that's what's going on there. Maybe my join wasn't the best, I guess. Because if I just joined irrigation on there and then that's missing there, and then I've joined stuff on top with a left join, it's probably not the best way to go. It might have been better to do like a bunch of full joins, and then throw out some data or something like that. That might have been a better. There's probably a better join method I could have used than this. Which is what I'm seeing looking at this now, and I guess I'll have to if people are interested and anyone like wants to know anything about joins, that's probably something. This is a good place to learn about joins, and joins are just super useful outside of SQL. They're big in SQL, right? Relational databases, but even just in like Excel analysis, using joins is super useful. But we'll just continue with this for now. So we look at where there's no date data, and then we're seeing like actual. What are we seeing? The Bahamas, Belize, American Samoa, Burundi, Ivory Coast, Cuba. Yeah, I mean these are Fiji. These are definitely countries. Basically, there's some rows. This isn't all rows, right? There's only 93. So maybe there's just some NAs in there. So I think this is an artifact of bad joins, and it should be investigated more deeply. Like if this was your job or like an assignment and I was being graded on it, then I definitely wouldn't. I'd go look into this. Like if I gave this to my manager, I'd be ashamed of myself. But this isn't. This is just me showing some analysis I did. So we'll move on. Yeah, so it deserves investigation is what my notes said there. And then we can have a look at like there's missing data for some years, right? Is where we've got to now. And so we can have a look at what like how many years of data there are available per country for just the irrigation data. So this is going back to the data set before it went into the data frame. Before we joined those 4 data sets together, this is just looking at the individual ones and just kind of working out what's going on. Because my joins are bad, right? My joins are bad, so I should look deeper. And so when I look into it, I just do a group by country and then count the number of rows for each country, and then go into ggplot, so I can just pipe into the ggplot and then just add layers to my chart. So this idea here is why I think R is like really good for EDA. Just the simplicity. And Python has some stuff like that, and like Pandas has it, but Pandas is an inferior tool, I would say, for this task. Yeah, that's what I would assert that Pandas is an inferior tool for exploratory data analysis. But it's still like a great tool for exploratory data analysis. It's just not as good as the tidyverse. Anyway, when I make this histogram, which is what I want, right? I can see, well, there's like 13 here with this, with all the data, all 16 years of irrigation data, right? There's 16 years, which will become an issue in a later date. And there's a whole bunch of things with some number below that, and there's a bunch with like 1 or 2 data points. We did the same thing for tractors, and we see, some tractor data has been collected for 50 years. So straight away, if we join these all together and trying to do like a cross-sectional thing and find like crop yields, well, we're not going to get more than 16 years with all the data. No, that is a bad interpretation of this chart. The horizontal... No, that is correct. Sorry, I was confusing myself. The height is the number of... yeah, the height's the number of years. Oh, man. It's the number of countries with that number of years is what's going on. This is the problem with histograms, right? That I had to understand. So what we're looking at here is we're looking at a histogram with the number of years for the distribution of number of years of data in that data set. So we can see that there's a bunch with potentially no data, and there's a bunch with then there's quite a few with like 16 years of data, and there's a lot with less. So straight away, one important thing to note is that 16 years is the maximum in the irrigation data set. If we look at tractors data set, we'll see that there's 50 years of data there. It's like the max for any country, and there's this kind of strange spike at 40 years. So I don't know, maybe, I mean, that's like an interesting thing that might have like historical implications. Then we'll get fertilizer. We got like 15 years, and then cereal yield is 55 years, which is about as long as tractors. So I'm going to guess that people have been interested in tractors and cereal yield for a while, and that makes sense for the World Bank, right? Like lending people money to get tractors. But still, we've got like 16 years, and then the highest in cereal yield is like 57 years. So at this point, I've found that, I thought it would be good to look at a country, because we've had a look through and we found we've got this data. It's kind of sparse, or not sparse, but there's like different lengths for different things. It's not an ideal scenario. I should kind of understand it better and have a look at it for a country. And I was like, well, Afghanistan is like cereal yield. Afghanistan's first on the list. It looks good enough. Then we get the chart, and I kind of fell down a rabbit hole here, because like this bit here, which is suspicious, like 2001 was 9/11, so why, like, what happened here, right? And then post 9/11, like, highest cereal yields they've ever seen. So then I was like, well, what are these other periods looking like? And then when I look into it, I find there's like this drop in crop yield, and then there's like the monarchy was deposed in a revolution here, and then like some communists took over around here, or was it communists? Yeah, so there was a socialist, an aggressively modernizing socialist government backed by the USSR, and then basically the USSR kind of enforced that on the locals, and kind of by force, until in 1989 there was the collapse of the Soviet Union, and there was like a civil war with this, which is why the Soviets were involved, was to stop the kind of the Taliban taking over. And then there's this kind of period of Taliban rule, and then 9/11 happened, and America started its occupation slash. I mean, clearly it's effective at like boosting cereal yields, right? So it's not just. There's something going on there. So there's like an interesting story there about what like America's implication and like the effects of America's occupation, or however you want to describe it, right? There's a lot of information in this one chart, right? Which is what's so cool about data, is that there's all this interesting stuff going on in this single chart, which is why I spent like a few hours looking into it and reading up in the history of Afghanistan. But then we might want to say, well, what's driving this? That's like an interesting thing, right? America's come, they've been pumping money in, America and its allies have been pumping money in. Clearly, is what's going on. Like it's been expensive. But something's going on here. So what's kind of driving that? Can we see any drivers? Do we have data to identify the drivers? So we can look at like the fertilizer for Afghanistan and just plot that out. Fertilizer per hectare use. So we've seen a big spike in around like 2012. Like tractor usage. Well, actually, tractor usage was like high. It was like increasing until the revolution, and then it's like decreased over time, and then we don't have data since the start of since like 9/11. So people stopped counting that, but which is very unfortunate because my guess would be it would look something like that, but I don't know. We also have the irrigation, and we're seeing, and this is only since since America moved into the region, and you can see that there's, I don't know, it's pretty that, yeah, there's something going on there. Whether it's like just variance around a line, or whether there's something else like that, whether there's like this is like a long-term uptick. Who knows? Like, I don't particularly trust this chart. I don't want to draw anything meaningful from it. In by itself, irrigation percent of land. Yeah, so 5.5% to 7%. It's, who knows what's going on, but it's post American occupation. So what's interesting is to kind of look at these things together. And this is we just don't know how many tractors are being used, right, in Afghanistan, in the modern day, and that's so like it is hard to see what's driving this. It's hard to know whether this is like real, right? And it'd be interesting to see. This is where like the economic freedom data would be interesting as well. Like you had like a monarchy, and then like a socialist Soviet-backed regime, and then you had like the Taliban, and like that's so you had the like a civil war, and then you had the Taliban, and then numbers drop, and then like after a civil war, for some reason the numbers dropped, and then the Americans come in and things kind of boom. So I mean, are these numbers real? Is it something to do with not having a socialist or kind of conservative tribal authoritarian thing, whatever you would like to describe the Taliban as, and then you've got like neoliberalism, right? Like that's where economic freedom comes in. But for all we know, like we're just missing like this major. We're missing tracked yield, but then it also doesn't look like tracked yield has had much impact. So is this like, are these numbers, we don't even know how reliable these numbers are, so there's all sorts of stuff going on here. And I kind of called it a day at that point on Afghanistan. I thought that was kind of interesting, but I should move on and do something else. No, I didn't. I decided to do some modeling. So there's a separate thing, like, so now moving on to modeling the data. So continuing this, the Afghanistan story, well, we can draw a line through, right, and tell, if we're looking at growth, we want to, like, in an ideal world, we should be able, like, we want serial yields to improve over time, and like a reasonable model is that it kind of grows potentially linearly. That, you know, if you're making a 5% or like I mean, maybe that's not a good model, right? But it is a model, that it grows at like 5% a year. And like, is that a good model? Because if it's like a 5% improvement per year, I mean, that's exponential. That would look like that. But I mean, I'm not sure I'd expect to see like bigger and bigger increments. You might expect to see something that looks more like that as it gets harder over time. Or maybe it's like a constant improvement in serial yield. But then why would you expect, like, if it's like a country that starts out with like extremely inefficient agriculture that's extremely like in a fertile place and has huge potential, you wouldn't expect like linear improvements necessarily, right? You might expect it to be kind of explosive and then catch up to the state of the art, and then like increase like that. So there's all sorts of interesting things that could happen. But when we just plot serial yield per hectare for all the countries in my data set over all time, I get something like this. And there's like a bunch of noise, and can't really see what's going on here, so I have to dig into it. But also, like, what's this? What's got these outrageously high serial yields? And then we go down and look at it, and we got like Kuwait, Oman, St. Vincent and the Grenadines, and the UAE. Don't know about St. Vincent and the Grenadines, but these three are like Gulf states. So, like, who knows what's going on there? I mean, maybe and there's all sorts of questions you could ask about that. But there's some Gulf states, they've got heaps of oil, and it's real hot. So maybe it's like small amounts of glass houses or something, and they've got, I mean, they've just, if they can get enough water in or something, I don't know. But that's what's going on there. There's a bunch of Gulf states, and like St. Vincent and the Grenadines is there. The colours don't necessarily match up, so it's hard to see what's going on. But that's the blue dots. So that's this. So it's like St. Vincent and the Grenadines staying up there. It's this line here. So, yeah, don't know if I believe that. Or maybe there's a bigger story. But anyway, if we move on and say, well, okay, so there's these outliers, but it kind of looks like maybe things are improving at time. We're just going to assume, for now, for this first model, that serial yields are distributed linear to date. So you got like a constant improvement over time in serial yields. So we can do that pretty easily, with some really nice syntax. I think it's nice because I like the tidyverse. But in using like tidy models and some of the tidyverse packages. So I take my serial yield data, group by country, and then nest it, which makes like a little data frame for each one in like a column. And then I can use the map function to take my data column and then map a linear model to it. So data, and then the data column gets mapped into there. And then we can say, well, I want serial yield, a linear model with serial yield this kind of explained by date. And I don't know if there's been improvements in this syntax. I think this is imperfect. I think there's a more tidyverse-centric approach to this that I believe people are working on. But then I can take, but anyway, I can take that model output, which is a new column called model, which has my models in, and then I can extract, I can kind of tidy that up using, and I can get the coefficients, and then some kind of advanced kind of object level summaries, like summary data from my linear models. So this is a really cool way of working with models in R. So we can run that. It doesn't take very long. There's not that much data to run all these linear models. But then I get like my R squares out of it, which is what's interesting here. And I can like plot my R squares as a histogram. Like there's a significant number that have nearly perfect explanations of like nearly perfect fits of this linear model. And so when we look at it, I mean, there's these kind of lower middle income nations, and as we take through, like China has had nearly perfect, like constant improvements. India, Mexico, Pakistan. Then we go to the other end. We got like Luxembourg. So I then went out and plotted the China crop cereal yield per hectare data, and it looks kind of like that. It's a bit up and down over time, but generally it's pretty linear. And then I just made a function to plot the data, save me some work. And so this is Luxembourg. And we're just going to add a title to it because it's easy. So we see Luxembourg, because this has got like a super low like coefficient, or like super low fit. Like it's a terrible model, and you can see it's a terrible model. There's no like constant improvement over time of that. New Zealand, because it was sort of middle of the mark. Maybe I should put like a note here saying what the R squared is in my function. But yeah, so this is home. So it's interesting to see what New Zealand looks like. At the moment, I have to go up here and like maybe find New Zealand. No, there's things I could do, but I'm not going to. And then America, and that's a pretty good model as well, like nearly constant cereal yield improvements. And then so the question is, well, why are some good models and some bad models? So if we just plot the coefficient of if we plot like the coefficient of the model, like the slope, or the constant improvement over time in like the goodness of fit, do we see some kind of pattern based on that? Not really. I don't see. Like the idea is that if you start with like a really high estimate, maybe it's hard to have like a constant improvement over time or something, right? But I mean, we don't really see anything like that. Filter. So what we can do here, I actually kind of look at this is the second time I look at it. So if we just add a filter where estimate is less than 250. So this is a cool thing at the tidyverse. You can kind of throw new functions in there. The reason I added that filter temporarily, is because there are these like outliers that were squishing my graph, basically. So I'm just going to throw numbers out until I get a tighter set of data, and then I might be able to see a better pattern. We don't really see that. Like we see like a wide. Some of the things with the highest estimates also have the highest like constant growth over time. So having high crop yields doesn't seem to have much effect on that. And that's just that's kind of where I ran out of. That's when I stopped. So that's just some of the stuff you can do. I should probably like dig into this more. These kind of model-based techniques are something I'm really interested in, and they're also useful for like time series, which is something that I work with quite a bit. in IoT, it's all, and like industry, it's all time series. So the idea, like an interesting idea, is if you have data that's like distributed like this. Um, uh, oh yeah. So if we have data that's distributed like this, like say we were looking at crop yields on the same topic, like crop yields of greenhouses, and then we had like patterns that looked like this, or like growth, or like anything that's like distributed that changes like by the season or by time of day, right? If we can then identify this pattern, which is like seasonal. So if we can like identify this seasonal, this regular pattern, and then remove that from the data, we'll end up with something that looks more. I mean, hopefully not hopefully not like sinusoidal itself, but some kind of random pattern, right? And then what interests me is the points that are like out of line. Or if you've got like a large number of these things, like if you're looking at greenhouses, right, and you have like hundreds of greenhouses, and you can find a good model that explains like a lot of the variance based on time of day or something like that, you remove that, and then you find like the points that are bad or the greenhouses that don't match your model. Like they should all be the same. There's a problem with your greenhouse. Well, that's interesting. Because everyone else, all these other greenhouses are following this pattern. Why isn't this one following the pattern? And that's something I'm interested in. I think there's a lot of potential in these models for that kind of stuff, and it's something you don't hear much about in the discourse at the moment, because everyone's chasing that machine learning AI hype, and there is a lot of value there for sure. But there's so many deep techniques out there that are really useful, and that are worth exploring on top of the machine learning, the AI, and things like that.